ఇస్తున్నాను సార్. ఇది ఆల్రెడీ ప్రాక్టీస్ చేసింది అలాగే ప్రాక్టీస్ చేయండి. అంతేగా మేడం? సార్ సార్ అవుతుంది సార్, అవుతుంది. ఒక్క నిమిషం. సార్ నా వాయిస్ వినపడుతుంది కదా? ఓకే.
Samir, am I audible to you? Yeah, okay. Just a minute. Is it clear to you?
ఓకే మనం ఫోన్ చూడండి ఒకసారి. స్టేజ్ క్యామ్ ఓకే కదా? ఓకే అయితే సరే, ఆఫ్ చేస్తాను మైక్. అంటే యూట్యూబ్ లింక్ నేను పంపిస్తాను.
పెట్టాను నెక్స్ట్ మళ్ళీ ఎవరైనా చేస్తారు what is going to class Thank you all of you. Welcome to the dignitaries, faculty, present media, and to everyone who have joined. We, Sai Lakshmi and Sujana Kirtana, thank you all for joining. You are gathered here for an international conference on computing, communication, and power technology. Before we begin, let me invite the dignitaries onto the dais. I'm glad to invite Professor P. Satish Ramachaudhary, Program Child IC3P 2022, Vice Principal RIT, Member FCC, and Michael Gray section onto the dais. We are delighted to invite Sri Raghu Kalinindi Garu, Chairman, Raghu Educational Institution, onto the dais. We are honored to invite Professor S. Lakshmi Narayana Garu, Everyone, please put your hands together to invite Professor K. Hemachandra Reddy Garu, Chairman, AP State Council for Higher Education, onto the dais. We are also pleased to have the Sri K.V. Sriram Garu, CEO of Andhra Pradesh, and the Technical Program Committee Chair, Dr. T.S.N. Murthy Garu, and Co-Chair, Dr. Samik Chakravarti Garu, and Principal of Raghu Institute of Technology, Professor S. Satyanarayana Garu, and Raghu Engineering College, Professor C.H. Srinivas Rao Garu, and faculty members. Now let's begin this conference in a traditional way with the lamp lighting ceremony. I request all the dignitaries on the dais to join the lamp lighting ceremony. Thank you all. Let's continue this with a prayer song as it is the link which connects us with the Almighty. So here is Bhavani and team for the prayer song. Asa, asa, गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि श्रीगणेशाय धीमहि. Thank you, Bhavani. Now I request Professor P. Satish Ram Chaudhary to give the opening remarks on the event.
So good morning, one and all. A warm welcome to one and all. I'm delighted to have several dignitaries and eminent personalities on the dais and off the dais. Once again, very good morning, sir. Honorable Chief Guest of today's function, Professor K. Hemachandra Reddy Garu, Chairman, Andhra Pradesh State Council for Higher Education. Chief Patron Sri Raghu Kalidandi Garu, Chairman, Raghu Education Institutions. Professor X. Lakshmi Narayan Garu, Chair, IEEE Vizag Bay. Sri K. Sriram Garu, CEO, Andhra Electronics, Kakinada. And my friend Vijay Kumar, Vice Principal, Raghu Engineering College. Professional members of IEEE of both engineering colleges. My colleagues from IEEE Vizag Bay section, Professor Murthy Garu from JNTU Vijayanagaram. Student members of IEEE student branches of REC and RIT, and all other students and of RIT and REC. and other dignitaries, keynote speakers who have joined the same program online. Once again, welcome you all. Welcome once again to the inaugural function of International Conference on Computing, Communication and Power Technology, IC3P 2022. The conference is intended to invite the latest research findings in computer science, electrical, electronics, and communication engineering fields. IC3P 2022 is the third international conference that Raghu Engineering Education Institutions are organizing. Earlier, we have organized two such conferences in the year 2016 and 2019, International Conference on Microelectronics, Electromagnetics, and Telecommunications. And they are popularly known as ICME 2016 and ICME 2019. In these two conferences, around 250 plus papers have been published in Springer lecture notes in electrical engineering book series, which are indexed in Scopus. And IC3P 2022 is the third international conference in association with IEEE Vizag Bay Section. And I'm very much thankful to our chairman, Sri Raghu Kalidendi Garu, and our director, Rahul Kalidendi Garu, and our secretary, Ramadevi Madam Kalidendi Garu, for accepting our proposal to organize a conference. This idea for this conference is discussed way back in 2021 June with our technical collaborator partner IEEE Vizag Bay Section, and we processed and forwarded. Once again, I thank Professor Lakshmi Narayan Garu for quick processing of conference application and getting acceptance from IEEE. So we're very fortunate, sir. We have Professor K. Hamchandra Reddy, Chairman, sir, APSCHE, as our chief guest. I'm thankful, sir, in spite of your busy schedule, you have given me time when I met in your office at Vijayawada. We are very much thankful, sir. In this COVID situations, you accepted our invitation, taking all precautions and all hectic schedules. You are here. We are very much grateful for that, sir. For this conference, we received 206 papers from various countries like Sri Lanka, Vietnam, Malaysia, and of course, all over India. Initially, the conference is planned to organize in offline mode, but due to this persisting conditions, we requested IEEE Vizag Bay and IEEE Council India, and they have accepted to organize in hybrid mode. The International National Advisory Committee helped with constant moral and technical support. I thank the special session chairs, Professor Sudhir from Vishnu Engineering College for Women and his team, for their valuable contribution to the conference. I would like to appreciate the efforts invested by the publication committee members in bringing out the souvenir in time. We would like to thank our IEEE student branch counselors, IEEE branch students of both colleges, Dr. Sridhar from Raghu Engineering College and Dr. Samir Chakravarti from Raghu Institute of Technology, who helped for different activities of the conference. In the conference, in the next 2 days, we have eminent speakers from abroad. 2 keynote addresses and 1 technical talk will be delivered by them. The first keynote address today is on antenna booster technology from fundamentals to applications by Dr. Jom Angwari, IEEE Fellow Founder and CTO, Ignion, who is Associate Professor at University Raman, Barcelona, Spain. And the second keynote is on overview of IEEE standards, IEEE circuits and system society standards activities subdivision by Dr. Kiran Gunnam, Distinguished Engineer, Machine Learning and Computer Vision, Western Digital, USA. And from India, we have invited talk by Dr. Satyasai Jagannath Nanda, Senior Member, IEEE Assistant Professor, Department of Electronics and Communication Engineering, MNIT, Jaipur. I wish all the participants, authors, and guests will have intellectual time during the conference these 2 days. Now, I request the TPC committee, Dr. B.V. Triples Chakravarti and Dr. T.S.N. Murthy Garu to give the TPC report. Thank you once again. Thank you all.
For your valuable words.
Morning, one and all. Thank you, Chaudhary Garu, for your kind invitation. Respected guests of today's function, Honorable Chairman, AP State Council for Higher Education and great visionary, Professor K. Hamchandra Reddy Garu, Chief Patron and Chairman of Raghu Educational Institutions, Sri Raghu Kalidendi Garu, respected Chair, IEEE Vizag section, Dr. S. Lakshminarayan Garu, Program Chair, and our beloved Professor Satish Ram Chaudhary Garu, Professor K.V. Sriram Garu, Professor Samit Chakravarti Garu, other dignitaries on the dais, off the dais, and my dear participants. A very good morning, one and all. It is indeed a great pleasure and honor for me to be here on this occasion, inauguration of International Conference on Computing, Communication, and Power Technology organized by Raghu Institute of Technology and Raghu Engineering College in technical collaboration with IEEE Vizag section. It's very glad to be a part of Technical Program Committee of IC3P 2022. On behalf of the Technical Program Committee, we are pleased to welcome you all. IC3P brings together academics, industry experts, and education leaders to discuss an incredible area of topics in recent trends. Our warmest thanks to our organizing committee colleagues, the Technical Program Committee members, the paper reviewers for their invaluable work in shaping the technical program, and not the least, all others who kindly submitted their papers to IC3P 2022. I congratulate the Dr. Dynamic Leader, Professor Satish Ram Chaudhary Garu, and his team for their great efforts since day one to make this conference a great success. It is not the first one, as he already said. He has organized two conferences earlier. So I hope and wish in future we will organize more number of quality events under the IEEE banner for the benefit of the faculty community as well as the students. Now I request from Professor Samit Chakravarti Garu, please submit a brief report on the technical program.
Thank you, sir. A warm welcome to all the dignitaries of the dais and all the dais. It's a great privilege to give the report of TPC committee. IEEE follows strict governance guidelines for evaluating its conferences and publications in an effort to ensure that IEEE events and their intellectual property meets the highest quality standards. And the TPC role is to ensure strict adherence of the conference to these standards set by the IEEE. We have received totally 202 papers, out of which 61 papers are given acceptance and permitted to register after peer review recommendations. To ensure quality, every submitted paper is subjected to a prerequisite check like similarity or plagiarism check. Similarity index above 30% excluding references are desk rejected and are not sent to the review and not even recommended for revision or resubmission. Papers which are through the pre-check are sent to the reviews. Minimum of 2 to 3 reviewers are chosen based on the reviewer's field of research or interest, and in many cases, the manuscript has been sent to more than 3 when the reviewers have not given their consent in time. The paper has been accepted only if the 2 reviews are positive and the similarity index is less than 15% excluding the references. To ensure uniform review process or evaluation of the paper, a review questionnaire has been prepared and made available to all the reviewers. The questionnaire has 9 checks on the manuscript, starting from the format, relevancy of the references, inference, proper credits given for the content adapted from others, composition of abstract and conclusions, and mainly results and discussions. We have given least preference to the review papers and papers with no research element. The reviewer count has crossed 80, and very fortunate to have reviewers from not just India, but from various parts of the world. Similarly, we have authors from several countries like Malaysia, Vietnam, China, and Sri Lanka. There are 3 special sessions, out of which one is interdisciplinary and related to machine learning and intelligent computing, while the other 2 are related to the advances in electronics and communication and computer science engineering. Dr. Sudhir Kumar, Chair IEEE at SOC Vizag Bay, Dr. Subbarao Mandava, Treasurer IEEE ComSoc SPS Vizag Bay, Dr. Rohit Anand, Dr. Nidhi, and Dr. Akila are the chairs of all these 3 special sessions. On behalf of TPC, we thank the team given to us who worked for several hours interacting with others in getting their final CRC in shape and standards of IEEE. I once again thank the management, the IEEE section for giving this opportunity. Thank you very much.
Thank you, Dr. T.S.N. Moti sir and Dr. Samit Chakravarti sir. And all the delegates, please join me. I request everyone to put your hands together. It's my honor to invite Sri Raghu the Chairman, sir, to give his message to the gathering.
Honorable Chairman of the State Council of Higher Education, Dr. K. Hanchandra, Professor Lakshman Garu, Chairman, IEEE Vice Section, KV Sriram Garu, past chair, Vizag Bay, CEO of Andhra Electronics, Dr. Murthy Garu, IEEE Vizag Bay, JETU, General, Satish Ram Chaudhary, my dear principals, vice principals, senior faculty members, and members of IEEE chapter of our institutions, all the participants from other countries as well as many other institutions. Warm welcome to you all and a very good morning to all of you. On behalf of Raghu Engineering Institutions, I would like to congratulate you for taking your time and efforts coming over and participating in this event today. And I congratulate my team headed by, like we said, dynamic Satish Chaudhary and his team, Chakravarti, etc., and other people, and other senior faculty, with their untiring efforts. Last few years, they have been doing great service, and then they are committed, and the result is being shown. And the EC department of R&D especially, setting an example as far as the research is concerned, and they are encouraging other departments as well. I appreciate department and HOD, of the management as well. It is indeed a very special day for us, especially for Raghu Group, and more special also because of the presence, the very presence of Dr. K. Chandra Reddy. It was a very great day for us, sir. I had the good fortune of interacting with him for more than 2-3 hours yesterday, and I was so thrilled, the kind of personality, unassuming, and I could not imagine somebody with this nature. He's a great researcher, best teacher awardee, hundreds of international publications, 40 odd doctorates. Sometime back, I was thinking that somebody with 20 PhDs under him will be a great thing. But I was surprised and shocked to see how he could do that number of doctorate and one postdoctoral research also he has guided, and lots of publications, etc. Speaks volume about his interest and passion towards education. He had many positions in the administrative side, and now he is at the helm of affairs as chairman of AFSHE. This is the first time I spent a lot of time with him, but I came to understand because people were telling me since long that Hemchandra Reddy is so good, so nice. I could not imagine that he's so good. Beyond that is interaction I had with him, and I very fortunate to have him here. A great human being. No. So in our state now, higher education is being guided by somebody like him, who knows in and out of the entire higher education, their requirements, everything. So nobody needs to explain him what is needed for an institution. Just now we have seen Lakshman Narayan was asking
something to Chandra Reddy garu regarding Reddy garu was speaking to somebody to get it done at their place. That is how he acts. It's a great honor and privilege for all of us, sir. I should thank our Satish also, taking the dare step of going to him and he asked me. And I said, yes. So, and there, and all these things happened so quickly. And we got you here. And then coming back to, okay, there are IEEE experts, they'll be talking much about it. I have only 3-4 minutes time, so I'll not be getting into that. At the same time, whatever it comes to my mind, like mostly faculty, researchers, and future researchers in the form of IEEE chapter students. I also belong to the teaching fraternity. So I also appreciate all your efforts. I congratulate, first of all the faculty members for being teachers. Choosing teaching itself as a profession is a great thing because the noblest of all professions is teaching profession. There's no other profession and keeping the integrity of the word. The first and the most important pillar is education. And the next, to my mind, next comes is health. First is education. If education is not there, health also won't be there. So we are the most important critical aspect. And we need to dedicate, because we have decided to be teachers, we need to dedicate ourselves for building the society, building the culture, and building number of generations to follow us. So we have great responsibility. To keep up the responsibility, we have to work passionately. To work passionately, we have to develop the interest, not just because I'm paid a lakh rupees, I'm working as a teacher, I'm working as a teacher to bring up the people year by year, hundreds of engineers, hundreds of scientists, hundreds of publications, and hundreds of understandings. Nowadays, in those days when we were studying, we don't have internet, we don't have all the journals available. Now, you find any new word, it takes only one day for you to understand what it is, another few days for you to understand every application of that. And within few days, you can see what is the latest situation of applications of this. Hardly 2-3 months, one can learn anything. And then can understand where the world is now as far as the technology is concerned. And then there are hundreds of projects which are done by many people across the globe. Just try to understand that is enough, especially for students. Just see any technology, understand what it is, use your internet facility, see what are the projects done, just go through them, at least try to repeat the same thing first. You get some confidence, and then after doing 4-5 projects, you'll get such a confidence that you can add some extra feature, you can have more scalability, you can refine it further such that its qualities or sensitivity has been increased and equipment is there, you made it more sensitive to the paper. So on one side, it's very easy to publish a paper. On the other side, it requires a lot of interest and passion to do it. I hope all of you budding engineers and budding faculty and the young faculty and senior faculty, you take it very seriously and see that in India, the research has to be increased to a great extent. The paper publications should not be only just for the sake of telling that I have 4 papers or 5 papers. The doctorates are not to just tell that I have become a doctorate. More than that, what kind of work we are doing and what kind of contribution we are having for the society and the culture and what kind of student community we are bringing up along with them. Every teacher publishes a paper in here and have 2 of the students' names included in that. Give an assignment to the student, ask them to study what about this and come back with us with some feedback. Then involve them, then the entire culture is built. Because we have to mold the students like that. A lot of research can be extracted from the students also. So I appreciate all the people, their time, their effort, their sincerity, and their enthusiasm in coming over here and participating remotely as well. And I wish you all the best. And thank you very much for this opportunity.
Thank you, Sri Ram, thanking yourself for your stimulating speech. Glad to invite Professor Lakshmi Narayan to give his remarks on this event.
ప్రొఫెసర్ ఏ హేమచంద్ర రెడ్డి గారు, శ్రీ రఘు కలదిండి గారు, సతీష్ చౌదరి, శ్రీరామ్, పిఎస్ఎన్ మూర్తి, ఎస్ సత్యనారాయణ గారు ప్రిన్సిపాల్, శ్రీనివాస్ గారు ప్రిన్సిపాల్, and people offline, some of the people who are there who are really delivering the interested talks. In fact, today morning when I'm just planning to come in the morning, Satish Chaudhary garu called me and said that you should be at 10 o'clock. And I thought exactly what should I speak in the audience. Then I thought that I will certainly ask certain points that will be helpful for the IEEE Vizag Bay, because I'm sitting as a chair here. I should do something good for the chair. I have a lot of things in mind to ask him. Before asking, I have to put some of the efforts what I have did. We have did, in fact. These are the things, sir, we did, and these are the things, requests we want. Naturally, that is the way how basically we need to ask our seniors. These are things we did it, these are things we need it. In fact, I didn't project anything. I am really blessed today. I could use the word blessed today. And I am with the Vizag Bay section is fortunate to have his blessings today to be the chief guest of this function. And it is the first, in fact, sir, I tell you here, we are earlier at the Hyderabad section. The conferences, etc., are to be permitted by Hyderabad. Today, we are able to give our conference by ourselves. This is the first conference what Raghu institutions are running the program under technical collaborations of IEEE Vizag Bay section. I think last 10 years or 15 years, there was no conference of IEEE happened independently in an institution. We conducted 5 conferences earlier, but IEEE itself done it, but not an institution. To give you a brief history of IEEE section for the knowledge of the delegates on the dais, we are basically a subsection in 2011 and full section in 2020. We have a past, we have 900 members. Today we are 1,506 members today. We have greatly conducted, sir, for your kind information, we have conducted a program for conference organizers, panel for chapters for entire India. We conducted IEEE extreme competitions to a lot of students benefited. We have conducted a mock extreme program also. Totally, this is the 4th international conference conducted for the last couple of years in this region. Thanks to Raghu institutions who really helped us a lot in making this thing. I think IEEE conferences are different from other conferences. That was the reason that we need to do that. If I really give the statistics, IEEE ICISSGT is 19% acceptance rate. Today also it is around 26 or 25% acceptance rate. A conference value will increase with the acceptance rate is low. Next in March, we are conducting one more conference in Geetham Institute of Technology. Our section has started with the pioneer talk of Professor Kastur Rangan, who is the ISRO's past chairman. We conducted a couple of events for the site programs, typically for the people who really poor people and this thing. And we conducted programs for tribal girls in Paderu and Aruku also for the benefit of the understanding of technical education in that area. We have conducted several programs for science education for the teachers of the high schools, 8th, 9th, 10th school teachers who teach science and mathematics. We used to go there, how to teach, etc. There are certain books we will give free also to them. We have conducted several programs with the AP State Steel Corporation in October 20. In fact, we have a YouTube channel also. IEEE Vizag has a YouTube channel which has around 1,000 viewers are there. Who typically we have all the programs what we conduct, we take in the live will be really displayed there. Typically, our membership strength is very good, and we have a lot of funds also is coming. This year we got, sir, CRR college got 400. This college also got $254, and other colleges also got. And we are planning to conduct a couple of events in this year for the purpose of the faculty, particularly NIRF workshop and NBA workshop. Also, we want to conduct with the Education Society chapter, and we already got a couple of summer schools also we received. We are also planning to have a machine also coming years, sir. And I think that these are some of the highlights what exactly I would like to mention here. Our Raghu Institute of Technology and Raghu College of Engineering both are the foremost front runners for the any event individually. It needs a lot of teamwork. When I really need a team of 5, 6 people or 6 people who are dedicated people, volunteers, I used to call a Satish or Samir here. Please send me a couple of people who can work for this event. By evening, they used to come to me and say, because IEEE doesn't have its own staff or faculty or anybody, it only comes with the other team members of other people only. Due to Corona also, we could be able to conduct this many programs last year. We got the highest award, Vizag section, in the small section category, highest incentive we got. Colleague got the best outstanding award, and one of our colleagues went abroad also recently for a meeting at some place. To request a couple of requests. Before coming here, my requests are fulfilled. I am blessed. Really, I am blessed today. Vizag section is really blessed with his presence. That I thank the Raghu Kalbindi Garu also for making this function his presence, and typically our Vizag section to the greater glories in coming years. Certainly, I need all your help in doing our section much better in coming years. Certainly, we will conduct more conferences. If you have any idea, please let me know. I will see that that idea should be materialized. Last couple of months also, we have done couple of programs regarding some kind of a small experiments of the COVID. We could get some funding also for that from the IEEE. CRR College got $400 last month. I think we students also kindly think on those lines. What kind of equipment can be done? What kind of things for the social distances? Can we do any kind of small equipment, whether it costs $100, $200? I'm talking because IEEE pays in dollars only. We will certainly give. Even otherwise, also our section will extend financial support to some extent for doing these programs. No issues on that. Therefore, we request all the members, and typically I request all of you kindly take membership of this thing. If you really see that our next educational policy or NIRF rankings, etc., professional societies has a typically very good role that exactly we are missing it. In the 100 marks, if you really split in this perception category, certainly 2-3 marks you can be gained by virtue of doing some kind of a professional activities program. This was discussed yesterday with NIT Warangal director, etc. We have discussed it. Therefore, with these few words, I really I'm blessed. I really am. Today is a very, very finest day in my life, because one day I got this letter that Vizag section has become a subsection as a section. I was, in fact, I am a very joy on that day. I was with the Vice Chancellor of Andhra University on that day. A phone call came from IEEE that you have become a section. Today, I was blessed that we are planning to have a better section geographical boundaries with the blessings of Hamchandra Reddy Garu. I am really happy on that. Certainly, I think that my team will work and promise you, sir. Certainly, we will do it, sir, with your kind help and etc. Thank you very much for giving the opportunity.
For your valuable words. It's my privilege to invite our chief guest, Professor Hemchandra Reddy Garu, to give his message to the gathering.
Okay, no issues. No issues. Respected Chief Patron and the man behind these institutions, Sri Raghu Kalidindi Garu, the chairman of Raghu Group of Educational Institutions. and the most learned man, the chair of IEEE Vizag Bay section, Professor S. Lakshmanaran, the most dynamic as well. And my very young friend, Professor Satish Rama Chaudhary, who came all the way to Vijayawada to invite me to this event. Only after coming here, I realized how much I would have missed had I not attended this meeting. Thank you for that invitation. And the two distinguished principals of the sister institutions, Professor Srinivasu, Professor Satyanarayana, and the Vice Principal of REC, Professor Vijay Kumar, and my colleague from JNTU Vijayanagaram, because I come from JNTU family, Sriram Garu, and all distinguished invitees, participants in this workshop, all those who are going to deliver the keynote lectures here in this conference, and those who have published their papers. Ladies and gentlemen, extend a very warm welcome and my best wishes on the occasion of the inauguration of this IEEE conference. I'm very glad to be associated. Let me once again reiterate that. I'm very, very happy that I could come here and address all of you. And more than that, the great man sitting there gave me a wonderful experience in the last 2 days. I mean, yesterday and today. Couple of hours of interaction, I could understand what he is and with what discipline he has built these institutions and whatever he is building. I should really appreciate, though Raghu, this is not my maiden visit to Raghu Engineering College. Way back in 2018, I guess, I was as part of an inspection committee. I came here, but not knowing much about it. I could gain an impression that it's a very decent college, but today, after all the interactions, now I understood Raghu is very rightly poised to emerge as a great engineering institution in the state of Andhra Pradesh. All said and done, we know that engineering is a professional education. And we all teach our students, we used to teach our students to behave very professionally the moment they enter into the fold of engineering colleges. Now, professionalism, the definitions keep changing now and then. But engineering education is well augmented and supported by the professional bodies, and IEEE stands very tall among all professional bodies, particularly for the students and faculty of circuit branches. IEEE is a role model professional body. Now, these professional bodies, whenever the educational institutions, they fail to behave very professionally, probably these professional bodies always stand there and guide the students and staff alike, in behaving very professional. Today, world is advancing very fast, and technology has become such a dynamic thing. And yesterday's technology is no more relevant. Every new day you're coming out with a new invention. And today people are talking about innovation, creativity, and entrepreneurship, startup. A lot of things are being talked about. Now, what we are expecting from the student is a comprehensive understanding and, very clear understanding, like, Sprite advertisement, only pyas baki bakwas. A very clear understanding on the fundamentals, and then how you expand. I was taken to his establishment by Sri Raghu Garu yesterday evening. I've spent almost an hour or so with him. I was quite surprised the depth of knowledge he has developed for a wide range of subjects. Be it condition monitoring, be it, automation, be it human resource management, be it finance, and be it, the sensor, be it the PLC. I was quite surprised because I'm 33 years old as professor in mechanical engineering. I have a limited knowledge in my subject, but I was quite surprised at him, looked at him with lots of admiration and asked him, what could be the reason why you could venture into almost every area and you are understanding everything? And he said, very humble man he is. He said, sir, I'm very solid in the fundamental knowledge. I understand the fundamentals very good. That makes the difference. And maybe I see a few students here. My appeal to all of you is this: have very clear understanding on the fundamentals. Now, today technology is changing and research is happening. But where is it happening? It is happening only at a very high places. What is a high place? Where you have a focused person, where you have a person who has complete comprehensive understanding on the area on which he is working. So therefore, the great place can be Raghu Institute of Technology. The great place can be Raghu Engineering College as well. As long as you are focused, as long as you are acquiring the fundamental knowledge, as long as you develop that curiosity to apply your fundamental knowledge, I mean, whatever knowledge you have acquired, to put it in practice and try to analyze what is happening in practice. He just now told, the world is in your palm right now. You type a search word and you have plenty of information in front of you. The latest developments in technology can be seen sitting in your room. You need not go anywhere. You need not be in Vizag. You need not be in Bangalore, or you need not be in Massachusetts. What is happening in Massachusetts? You're sitting in Raghu Engineering College. You can always see that. So information is freely available. How you process this, how you make your mind, how you develop your clarity of thinking. I always quoted this example wherever I went. I suppose I have 10 minutes of time. So let me do it as quickly as I can. I always quoted this incident, what happened to me in my life. A small incident, let me narrate. I was in final year BTech then, and one fine night we had our dinner. We just came out. Those days we never had mobiles and TVs, hostels were only centers where human interaction happens, nothing else. No electronic gadget was there those days. And normally it's a practice after dining, we all come out of the hostel, if it is a moonlight, that's a wonderful thing. We keep talking, sitting in groups, and then we keep discussing. Suddenly, one gentleman got an idea that he challenged the rest of the people to go blindfolded and walk all the way about 200 meters, touch civil engineering block of the college. So that was the challenge he has opened. And many people, it's all fun, a lot of fun going on. Everyone tried and they failed. Everyone was finding it very difficult to reach blindfolded the civil engineering block. And it came my turn. I had my action plan very clear because, for a long way of 200 meters, the building is 200 meters away. There is a narrow pathway. On either side of the pathway, there is tall grown grass. So I chose to leave my chapel and go walk barefooted. So my plan was I keep 1 foot in the pathway, 1 foot on the grass. So my vision is very clear. So I thought I can go reach, and thereafter it's a plain land, and maybe 50 meters there, probably I can go and touch it. So with that action plan, I went. I was going very well. People were encouraging me. I could very clearly hear to all the ecstasy and the encouragement what they are giving. That gave me an indication that I am on the right way. And in my assumption, when I had to stretch my hand, I'll touch the building, the destination. I extended my hand, I stretched my hand, I touched a tree. And the tree was not in my imagination. For a moment, I thought I'm at a wrong place. The challenge was it should be completed in 15 minutes. And in my imagination, for a moment, I thought I'm in a wrong place because in my imagination, is a strap inside a flower. It was deeply engrossed. He did not realize, and it was strapped. It is saying this. This night will pass out. Paswan Udishya. Surya Udayisthana. The sun will rise in these. Ashishyati Pankajashri. This flower will open, once again, for myself. And I will fly away very happily. This was the discussion. But at the same time, what happened? This was the thinking of this. And at the same time, what happened? A herd of elephants landed in the pond in which it is struck. Now, I need not explain. When the elephants enter into the pond, what is the fate of the flower? What is the fate of this insect, which is trapped inside the flower? So you cannot be complacent. Today we are very complacent that you are all getting IT jobs. But tomorrow, India is all set to grow in manufacturing sector. India's power requirements need to be doubled today. Today we are talking about non-conventional energies like solar, wind, and grid balancing is a big problem, instability, and then we are talking about hydrogen energy. And whatever the installed capacity of power till today, we need to be doubled, mind you. And India is still a developing nation. It develops. Yardstick for the development of a nation is the per capita energy consumption. If energy consumption, compared to Americans' energy consumption, our per capita energy consumption is only 1/3 of it, or even less than that. So we are going to use more and more energy. Then power sector is very, very important. Manufacturing sector has to grow, and chemical industry is supposed to be the industry for the next decade. Whole lot of inventions are happening, and on top of it, all of that, today is people are talking about industry 4.0, and then IoT technology is then every supported by the circuit branches knowledge, like microprocessor, programming, and then database, artificial intelligence. They are all fast coming into it. But you see, having knowledge only in a skewed area, in a limited area, cannot help any country for that matter. And we should be gearing up for the future growth of this nation. And today, there is a very strong need for all of us to develop or produce high quality graduates in every discipline. That's what I was talking to Rahul yesterday. I asked him, see, he is owning a company and he is recruiting people. I asked him, how are you? Are you really happy with these guys who are working in a core domain? He said that people are not really interested to learn the concepts in the core domain. See, things can go very easy. That's what I said. When you close your eyes and then everything, assume everything beautiful, you obviously tend to be very lethargic, lazy. But you need not, you cannot, or we cannot afford to be lazy at this point of time. And that's where my appeal, because it's a right mix of teachers as well as students. My appeal to all the teachers here, probably we need to revisit the fundamentals, go to the classroom with all the solid knowledge. And today, we are heavily supported by animations. When I started teaching my mechanical engineering, and I was trying to, explain a gearbox, synchronous gearbox, probably I had to draw for about an hour on the blackboard, all the gearbox. But today, click of a button, you will have the animation, what gear is, how it is moving. Everything can be explained so effectively. And today, the teachers are heavily supported by the technology. Use the technology, drive the fundamentals very, very solid, and let them appreciate, let them understand what is the concept behind it, and then let them start applying it. And that is the surest way this country can go forward. Particularly the state of Andhra Pradesh, we are intended in creating a knowledge capital in the state of Andhra Pradesh. A lot of importance we are giving to higher education today. We are trying our best to bring in the reforms, but the only thing is it is finding it difficult to calculate, particularly due to pandemic and then the lethargy or the belief system that the educational institutions have developed over a period of time. We need to unshackle everything. We need to, reposition ourselves. Probably we need to take fresh knowledge back into the classrooms and use all the technology. And I see, I'm a mechanical man. I see a whole lot of topics are covered in this conference and papers are presented and papers will be presented. I'm very, very happy you subjected the papers to plagiarism and you only allowed only less than 15% commonality. This is the quality, that's what we wanted everywhere happening in the state of Andhra Pradesh, particularly the state of Andhra Pradesh, deprived of all industries. We are even studying to have a capital and revenues are very dwindling and very difficult to manage the finances of the state. At this point of time, we can rejuvenate, we can emerge stronger with highly qualified graduates. Be focused in whatever you do and be very clear in whatever you do. Don't do anything in confusion. At every point of time, if you're confused, please go to your teacher. Get it clarified there and then go. Vidyancha, Vidyancha Estadvedo Vaitsa, Avidyayam Muktinta, Vidyayam Uttamashmame. I think all of you know this Isha Vesha. Vidyancha, Avidya. Vidya is knowledge, Avidya is ignorance. Vidyancha, Avidyancha, Estadvedo Vaitsa. Ubhayam, both of them, you learn them equally. Because only if you know what you know, you cannot expand into what you don't know. So you always should be very clear about what you know and what you don't know. Slowly expand your boundaries for a simple reason that ignorance takes you to the shores of death. Knowledge gives you nectar. Vidyayam Uttamashmate. Vidya will give you amrita. So with this very small message, I take once again this opportunity to congratulate Raghu Institute of Technology and the IEEE Vizag Bay section for organizing such a wonderful conference here. I only wish a learning experience for all the participants. You have very renowned people talking, delivering their minds and their knowledge here. Probably stay alert and get benefited to the conference. All the very best to this conference.
Now it's time to felicitate our chief guest. So I request our dear chairman to felicitate Professor Chandra Reddy Garu and present him with a memento. For all his support. Thank you all. Now I invite Dr. Gutteswar Sahu, Sir, Dean R&D of Raghu Engineering College, to give the closing remarks and vote of thanks.
Good morning. Good morning, all. Respected Sri Raghu Sir, Chairman, Raghu Educational Institute, Your Excellency, Chairman, APCHC, and Chief Guest for today's event, Professor K. Hemachandra Reddy sir, Honorable Narayan sir, Chair, IEEE Vizag, Bay, Professor K. Satish Ram Chaudhary sir, Chair of IC3P, and Vice Principal, Raghu Institute of Technology, and our special guest, Sri K.V. Sriram sir, CEO, Andhra Electronics, Kakinada. Uh, Honorable guests, colleagues, dear authors, and participants, it is a great privilege for me to express vote of thanks for this inaugural session of this event on behalf of organizing committee of IEEE International Conference on Computing, Communication, and Power Technology 2022, jointly organized by Raghu Institute of Technology and Raghu Engineering College in technical collaboration with IEEE Vizag Basics. I take this opportunity to thank IEEE Vizag Basics and for technically co-sponsoring this event. Let me express my gratitude to our chairman, sir, K. Raghu, sir, for all his support and motivation. Really, sir, your presence is itself is a motivation and inspiration for all of us. We offer our sincere thanks to Professor K. Hemchandra Reddy, sir, today's chief guest, for his presence and accepting our invitation and being here today with us. Your speech was really encouraging one, sir. Thank you, sir. And giving the real-time examples and the importance of core branches. Thank you for all these awareness, sir. I take this opportunity to welcome from USC, Dr. Satyasai Jagannath Nanda from MNIT Jaipur for accepting our invitation to grace the event with their online presence. We are looking forward to hear from you, all of you, sir. I keep on record our in-depthness to Srimati Ramadevi Madam, Secretary, Raghu Educational Institute, Sri K. Rahul Verma sir, Director, Raghu Educational Institute, Professor Satyananda, Principal, REC, Professor C.S. Srinivasu sir, Principal, REC, Professor A. Vijay Kumar, Vice Principal, REC, Dr. Samir Chakrabarti, Dean, R&D, RIT, and Dr. T.S.N. Murthy sir, Assistant Professor JN2 Kakinada, and Chair IEEE ComSoc Chapter. Richly deserves our gratitude, and I offer the same. We remain grateful to the program chairs, Professor Satish Ram Chaudhary sir, Vice Principal RIT, and Professor S. Lakshminarayan sir, Chair IEEE Vizag Bay Section, for their timely planning and execution. Thank you by leading from the front, sir. I hereby acknowledge our sincere thanks to chairs, co-chairs, reviewers, deans, HODs, faculty members, staff members, and student volunteers from both REC and RIT who directly or indirectly involved in this conference. We extend our special thanks to all the authors and participants for participating in this prestigious IEEE event. We are looking forward for your active participation. Thank you all.
Everyone stand up for the excellence.
and it is in presentation mode right now. Yeah, we are sliding from 1 to 2.
Okay.
Why this topic and so on. Yeah, good.
Okay. Okay.
So,
Okay.
sir, the thing is, we are telecasting it live on YouTube as well as through our website, IEEE student branch website. So there will be few members who will be joining on Google Meet, while the remaining people, all the members, student members, IEEE professional members of this region, and the participants, others, all of them will be joining through that YouTube link.
Okay.
Yeah. So only few people will be joining in our Google Meet. For the remaining people, they will be listening to you on YouTube.
Okay, that's fine.
Yeah.
And
Yeah.
will be the YouTube link available after the conference?
Yeah. Yes, sir. You want? Yeah. The YouTube link will be available, and it is always live, sir. I'll share it with you.
Okay. Yes, please. Yeah, it will be great.
Yeah. So we'll start. We shall start in 5 minutes, sir. Is it okay for you?
Yeah, it's fine. It's fine.
Yeah, we have few people who, when a few guests again in our college, they just were they went for a campus visit. So once they reach here, we have an auditorium and we have a laboratory where this screen will be shared on the big one. Okay, so all will be sitting there and listening to you. So I am sitting in another in my room just to see that the meeting is uninterruptedly going on. Okay, so we are just waiting for those people, but we for sure will start in 4 minutes, exactly at 1:30.
Okay, that sounds great.
Yeah. Yeah,
Good
hello.
afternoon, Amir. How
Yeah,
are you doing?
yeah, we are fine, sir. We are doing good, and hope you are also doing well.
Yeah,
Yeah, we are very delighted to have you here for the IC3P once again.
it's my pleasure, and thank you for inviting.
Thank
Always
you.
glad to be here. Yeah,
Yeah, we are blessed for that actually. Thank you very much for that. Nice gesture, sir. And Satish and my chairman and all the chairman of IEEE Vizag Bay, everyone they have joined online on YouTube in a particular auditorium. They have gathered and they were actually listening to it. I'll share with you all the photographs.
okay,
With your permission, I'll be starting the recording. However, it is YouTube live. And shall I start, sir? Okay.
okay. Yeah,
Yeah.
whenever you want, I'm
So
ready.
yeah. So meanwhile, I request Mr. Akash.
Yes, sir.
Yeah, please introduce the speaker to the audience.
Say warm good afternoon to all the participants. I am honored to introduce our keynote speaker, Dr. Jam Angira, IEEE Fellow, founder and CTO at IGNIAN, Associate Professor, Professor Titler, and belongs to Electronics and Telecommunication Engineering Department at Universitat Raman Lul. Jam Angura is the founder and CTO at IGNIAN. Prior to this, he was the partner and R&D manager at Fractus, Barcelona, Spain. He is also serving as associate professor at Universitat Ramon Llull, Barcelona, Spain. He is an IEEE antennas and propagation distinguished lecturer. He holds more than 150 patents, and his bibliography is listed in Who's Who in the World and Who's Who in the Engineering. He is the author of more than 250 scientific widely cited papers and international conferences with the citations above 7,500 and having the H index 50 and I-10 index of 150. He is the author of 6 books and he has participated in more than 21 competitive research projects financed by Spanish ministry. He is the author of 6 books, directed more than 100 bachelor's and master's theses and 3 PhDs. He is the inventor of virtual antenna technology, which enables full function of multi-band wireless connectivity to all the wireless devices through a miniaturized and off-the-shelf antenna boosters. He has taught more than 20 antenna courses around the world: USA, China, Korea, India, UK, France, Poland, Czech Republic, Tunisia, and Spain. With over 21 years of R&D experience, he has developed a part of his professional experience with Fractus in South Korea in design of miniature antennas for large Korean companies such as Samsung and LG. He has received several national and international awards. He is the associate editor of IEEE Open Journal on Antenna and Propagation, Electronics Letters, International Journal of Electronics and Communications, and reviewer in several IEEE and other scientific journals. He is Vice Chair of Working Group Software and Modeling at European AAP. Thank you, sir.
Thank you to you.
Yeah, thank you, Akash. Thank you for the nice introduction. It's really exhaustive bio, sir. We are really blessed to have you once again. And you will be talking about the antenna booster, which is your core research area and which is the foundation for your virtual antenna, I believe. So once again, you are sharing the latest research findings in this particular area would be definitely helpful to all the people who have joined here, both online in the virtually on YouTube link as well as Google Meet, as well as who have gathered in the auditorium. And just for your information, we have here with us in the meeting the IEEE chair of Vizag Bay section and secretary and vice chair of IEEE Vizag Bay section, all the HODs, Department of HODs of Department of ECE, Department of CSE, Department of EEE, Department of Civil and Mechanical Engineering, principals of Raghu Engineering College and Raghu Institute of Technology, as well as we also have one special guest, Sri Sriram Garu, who is the CEO of Andhra Electronics, who is also with us today for this keynote lecture. And we are also blessed to have chief guest Professor K. Hemachandra Reddy Garu along with us. However, we will be moving, he will be not available throughout the lecture, but out of his interest, he has joined with us. These are all the people and elites of this region and this particular Andhra Pradesh state who have joined with us for this session, sir. So now I request you to share the screen and start over, sir. Thank you.
Okay. First of all, let me say Happy New Year to everybody. Also, thank you, Professor Satish and Professor Samir, for organizing this event and inviting me. And thank you to all the audience to be here. It will be glad to share with you the latest advances on this game changer technology that we call antenna booster technology. So let me share my screen and let's get started. Can you see my screen? Hello, can you see my screen?
Yes, sir. Yeah.
Okay.
Thank you. Thank you.
Okay. So it's glad to be here. Thank you, everybody. And well, it's the title of the presentation today. It's about this technology that we call antenna booster technology, which is a game changer in the IoT space. And today we are going to travel from fundamental aspects to applications. And my name is Jaume Anguera. I am CTO and founder at the company Inaugural in Barcelona, as well as associate professor at Universitat Ramon Llull. Thank you, the Ragu Institute of Technology and Ragu Engineering College for organizing this event. It's always a pleasure to be here. This is the journey that we are going to follow today. First of all, why antenna booster technology? Then we will go to the architecture, some fundamental aspects to understand the physics behind antenna booster technology. And then we will see how this technology is useful to design devices that need to operate single band operation or multi-band or MIMO, and also what is the role of reconfigurability in this technology. Then we will go to the point of matching network. What is the role of a matching network in this scenario? And we will compare antenna booster technology with other technologies. Then we will draw the conclusions, and I will provide some reference for you if you want to go with further research for your students. And also I will share my PDF file so everyone can have those reference for extra study. Well, as you know, we are entering this IoT world where all things will be connected, from parking sensors, smart cities, smart home, smart agriculture applications, where we can have a better use of our resources. So all these things will have sensors that they need to capture data from light, air quality, humidity, temperature, and so on. And at the end, they need to send this data into the cloud. So this means that all these devices, they need to have an antenna that is in charge to efficiently transmit this information. So as you can see, there will be, well, many kind of applications. So the antenna will have a very, very important role in this new scenario. The technology that we are going to see today, it's very suitable in the frequency range from more or less 0.4 giga up to 10.6 giga, where many of the wireless protocols are allocated. Narrowband IoT, LTE, 4G, 5G, ultra-wideband, GPS, LoRa, Sigfox, Wi-Fi, and so on. And here you can see on the left the forecast of the IoT connections in red. So the forecast predicts that by 2025 there will be more than 20 billion of connections. This means a lot of devices. This means a lot of antennas. So this puts a lot of pressure into companies, institutions, universities to research in finding new antenna technologies that fits in those small devices, and at the same time they provide efficient communication. So there is a good appetite in the market to research on this topic. So let's go back to the previous antenna technology, which is based on geometry. As you can see in this slide, we have some wireless devices. In this case, they are mobile phones, where in each mobile phone, you can have one of these antennas for multi-band operation. All these antennas, they are different. They use a particular geometry to make the antenna small and multi-band. Usually, the antenna position is at the edge of the device. So one conclusion, as you can see here, is that they rely on geometry, on this complex geometry, to compact the antenna into this small space. So although this approach is efficient in terms of bandwidth and efficiency and so on, it's not inefficient in designing these antennas, because for every single device, you need to start from scratch and design a new antenna, a complex antenna for every single device. So the point here is that there is no a single antenna that can be reused across different devices. Also, if you change in this case and in this case, the mobile phone is almost the same brand, but the antenna is different because a tiny change in the frequency bands of operation needs to create a new antenna. So you need to have a different antenna because the platforms are different, and you need to have a different antenna because you need to change the frequency bands of operation. So with this pain or with this issue in mind, what we thought back in 2007 is, okay, can we somehow substitute these complex antennas by something that can be small, and at the same time we can reuse for every single platform and no matter the frequency band of operation? So we thought that perhaps with a tiny element, we can excite currents on the ground plane of the device and make the antenna the ground plane of the device. So to do that, you don't need a big antenna like this, but you need what we call an antenna booster. So the reason what we call antenna booster is because it boosts currents on the ground plane, so it makes the ground plane the antenna. From the commercial point of view, at the company Inaugural, where we invented this technology, we call it virtual antenna, because at the end, this is not as an antenna per se, but it's like an exciter, it's a boosting element. The ground plane or the device itself, it's the major role, it's a major player into the radiation process. So with this idea in mind, we did a lot of research and we filed some patents. Now they are granted. So we are happy that these are the first documents, the first available technical documents that appear in the literature as patents about antenna boosters. If we go back in time, by 1983, most of the antennas for wireless devices, they were external monopoles. As you can see here, this long stick, about 20 millimeters in length, they were mainly single band. Then by 1999, 1996, more or less, the first internal antennas appear, still with a big size of 10,000 millimeter cube and still single band. And then they started to appear the first multi-band antennas. As you can see, they still rely on complex geometry. The volume decreases as the time goes on, but we have a volume about 1,000 of millimeter cubes. So the big breakthrough is with the apparition of antenna booster, where you can see that the volume is more or less 10 times smaller yet providing the same performance multi-band operation. You can see here in my finger, this is a real product. This red component, as you can see here in my screen, is this one. It's a very tiny element with only 12 millimeter to provide operation in the 4G space. So they are small components, they are multi-band, and they're off-the-shelf components. This means that you don't need to design from scratch a new product, but they are ready to use. So each time you need to design an IoT or a wireless device, you don't need to start from scratch the antenna design. The antenna is like an amplifier that you can get it and you can install in your PCB to start designing your device. And we are glad that this technology is already adopted worldwide. These are some examples of open IoT platforms of the main players. As you can see, Nordic Semiconductor, Sequans, Sierra Wireless, Cably Wireless, by the way, from India, and the Things Industries. These are IoT sensors, plenty of sensors for humidity, gas, air temperature, velocity, and so on. And they need to capture data and send it into the cloud thanks to this red component, which is an antenna booster. So an antenna booster allows a wireless device to operate for any frequency band and for any platform. So let's have an example. In this case, on the left, we can have one platform, a medium platform, and a small platform, like a smartwatch in size. No matter the size of the wireless device, we can always reuse the same antenna booster. You can see this is the same antenna booster. And the only thing that changed from one platform to the other platform is a tiny component here that we call a matching network. So thanks to this matching network, the designer can freely choose the frequency to operate at. Moreover, imagine we need to design for a particular device some frequency bands. So we have an antenna booster and a particular matching network. If in a future project we need to update the same device but to include new frequency bands, we don't need to change the antenna element. The only thing we need to change is the matching network. So as you can see, this is a totally different approach that designing antennas with the state-of-the-art technology that is shaping the geometry. In here, we don't shape any geometry. We rely on the antenna booster and we change the matching network. So in a sense, designing wireless devices with antenna boosters look like more like a microwave problem than to an antenna problem. So this is a summary of antenna booster technology. We have small components, they are multi-band, they are off the shelf, and also these components can be assembled into a PCB of a wireless device through a pick and place procedure. This is an automatic procedure that takes the antenna booster and assembles on the PCB like any other chip. So this minimizes the risks when building thousands and thousands of devices with this technology. So the kind of applications that where this technology shines is for trackers, smart meters, smart home and city applications, modules and sensors, so everything within this frequency range, 0.4 up to 10.6 giga. Let me put a video that summarizes the main aspects of antenna booster technology.
In this super duper smart modern world, connected things are everywhere. Whether you're managing a fleet of trucks, running a smart city, or just checking your fridge, you'll be using antennas to plug into the mystical wireless IoT world.
Last night, you ate 3 pizzas. Shall I order more?
Shh, fridge! Don't be so smart. Anyway, for you guys trying to figure out which antenna is right for you, the whole process can drag and suck up all your patience and money until you find yourself screaming, "Please help me!" But now, your antenna nightmares are over. Introducing the one, the only virtual antenna. This little genius is multi-band. It works to any standard or frequency. NB-IoT, LoRa, Sigfox, Wi-Fi, GPS, 3G, 4G, 5G, or whatever G they come up with next, probably 6. And because it's tiny and delightfully versatile, it'll fit in any wireless product, regardless of the form factor and frequency band. Your friendly new little antenna component works just like another chip. Need to reduce your time to market? Use virtual antenna on your project so you can move fast. On to the next one. Or sit back, relax, and
Eat more, Peach.
fridge. Oh, go on, man.
Okay. So now let's see the architecture of antenna booster technology. It's very simple. First of all, what we have is the antenna booster. Here it represents a PCB, a printed circuit board of a wireless device. So we have the antenna booster, then the matching network, which is between the antenna booster and the transceiver, the RF module, which is in charge of transmitting and receiving the information, and then the ground plane. The ground plane plays a very important role, as we said before, because the antenna booster excites current. So depending on the size of the ground plane, we will get more or less bandwidth and efficiency. So thanks to this architecture, antenna booster components are 10 times smaller in volume than any other antenna product. So let's illustrate how a matching network helps to select the frequency band of operation. So imagine that we want to have a device with an antenna booster, and we seek operation at a single band operation. This is frequency, and this is reflection coefficient. So in this case, we have a simple matching network with 3 components. A matching network comprises inductors and capacitors. So in this case, we have for LoRa single band. But imagine that we need to have multi-band operation. Then we design a different matching network, in this case with more components, because now we have a multi-band operation. Imagine this is for narrowband IoT. You have 800, 900 megas plus 1800, 900, as well as 2 gigas. And imagine that you want more frequency bands. So we design a new matching network, and in this case, we expand the bandwidth in this high frequency band. Now we go up to 2.7 gigas. The good message about this new way of designing wireless devices is that the design of the matching network can be totally done by software, by any microwave circuit simulator. It's able to synthesize the matching network topology as well as the values, even commercial values, that you need to operate at the frequency band of operation. So everything can be in somehow software driven, automatically done. And this is fast and easier than designing an antenna from scratch. What is the role of the ground plane? The ground plane of the wireless device. In this slide, what we have is a small PCB, like imagine a smartwatch, to a medium device and a large device. Here we have the total efficiency. 100% is the best efficiency, 0% is the worst efficiency. At low frequencies, so around 900 and lower frequencies, the ground plane plays a very important role. So for small platforms, you will get less efficiency than if your device has a large size. So this is very important because for designing wireless devices, not only you should look to have a very nice shape in terms of marketing, but also physical law matter. So if the device is going to be small, then the efficiency is going to be not as high as if your device is larger. For larger frequencies, so beyond 1.7 giga and so on, this is not as critical. So you can see that the efficiencies can be large enough. Here, the challenge is always designing wireless devices when they need to operate in the low frequency range below 900 megas, more or less. Let's see some fundamentals, some basic fundamentals. Why this technology works being so small? So at a high level, I don't want to go deep diving on this, but let's use this theory that it's called characteristic mode theory, that allows us to understand when we have a conducting surface, this is the ground plane of a wireless device, how good you can excite this ground plane depending on frequency. So in this graph, what we have is frequency on the horizontal axis, and this number that is called modal significance, from 0 to 1. If it's 1, this means that you can excite the ground plane very good. If it's 0, you cannot excite the ground plane. So for instance, at this frequency region, about 900 megas, it means that in this blue line, there is one mode 1, that can be excited. So this is very useful, and let me put an example. Let's imagine a drum, an acoustic drum, okay? The membrane, if the membrane vibrates, it's gonna make a sound, boom, okay? To make that membrane vibrate, what you need is a stick, but not a big stick. You need a stick small enough to push in the membrane in a particular point of the membrane. So here, the membrane will be the ground plane. If the ground plane vibrates, this means that you are going to radiate, you are going to have an efficient system. And the stick that pushes the membrane to vibrate is the antenna booster. So depending where you put the antenna booster, you are able to excite the ground plane currents. So let's illustrate on this slide. We have an antenna booster that is in the corner of the ground plane in green. And we have another situation where this antenna booster, it's a metallic object, a 3D object, it's in the middle of this long edge. Both antenna booster, they have the same size. Let's see what happens. Let's compute the bandwidth with some formulas, okay? And what happens in the low frequency region is that the blue case is much better than the green case. And the reason is why. Why is the blue case much better? Because if we go to the characteristic mode theory, for this low frequency region, there is one mode that can be excited, which is the mode 1 in blue. And this mode 1 in blue, if we look at the electrical field distribution, it has a null, a zero distribution in the center, and a maximum at the edges of the ground plane. So that's the reason that if you put the antenna booster at the corner of the ground plane, you are going to excite this mode. But if you put the antenna booster in the middle of the long edge, since you have a null, you are not going to excite this ground plane currents. So as a result, the bandwidth is very small. However, this situation is not as critical in the high frequency region, because in the high frequency region, there are other modes, in this case, mode 4, that it has a maximum of electrical field at the center. So if we put an antenna booster in this position, we can excite this mode, and in return, we have some bandwidth. So as a summary, the position of the antenna booster matters to excite currents, and in return, to get bandwidth and efficiency. Always, if you want to deep dive into this physics behind, you can have a look at this paper that I will share with you at the end of the presentation. Okay, so now that we know that an antenna booster, usually the corner of the ground plane, it's a good position, let's see what happens at the radiation efficiency. As you can see, we use a source, an RF source, to excite the ground plane with this antenna booster. And in return, we have currents, and the radiation efficiency can be very high with a very tiny antenna booster, only lambda over 50 at 900. This is only 5 millimeter antenna booster. It's pretty small. And we can get high efficiency. But what happens with the impedance? If we compute the impedance, as you can see, the input impedance is reactive. The system is not matched because it's very far away from the center of the Smith chart. So this is a problem? No, because now the second step, it's okay, now that we can excite currents and that we know that is efficiency, the second step is, okay, is to use a matching network to put this input impedance in the center of the Smith chart. So as we saw, the position of the antenna booster matters, and here we have real examples of some open IoT platforms. As you can see that as a rule of thumb, the antenna booster is always at the corner, and this is a feeding line that goes to a matching circuit, and then it goes to the transceiver. As a rule of thumb, placing the antenna booster at the corner of the device provides always the better bandwidth and efficiency. So now what happens with the input impedance? The question is, okay, this is an antenna booster on a PCB. This is the ground plane. This is a 50 ohm transmission line, and we measure without any matching network. And this is the input impedance that we get. It's non-resonant from very low frequency, 0.8 gigas, up to 2.5 giga. So the question is, can we match this reactive impedance and put it in the center of the Smith chart? Or even more challenge, can we match simultaneously this frequency region about 900 and a high frequency region about 2 giga and put in the center of the Smith chart? The answer is yes, with a matching network. So here what we have is the antenna booster. We have the transceiver, which transmit power in blue. And what we want is, okay, to have all this power that is transmitted by the transceiver to reach the antenna booster and to radiate into space in order to send information to other devices. So what we need is between the transceiver here and the antenna booster, we need a matching network. And if we design a matching network in a proper way, what we are going to ensure is that the all incoming power will be entered here and will be radiated into space. If you want more details on how this matching network works, you can always go to this tutorial. But this is very simple. Okay, let's illustrate with this example. In red, we have an antenna booster, very small, only 12 millimeter. It's lambda over 30 and 900 megas. In yellow, we have a ground plane representing a PCB of a wireless device. And if we compute the input impedance at 900, you see that the input impedance is reactive. It's very far away from the center of the Smith chart. In terms of S11, it's about -1 dB. This is a very poor matching. But if we add a matching network using inductors and capacitors, we can modify this input impedance and put in the center of the Smith chart. And now you can see that 0.1 and 2 becomes 3 and 4. They are close to the center. And in return, we have an S11 that is below -12 dB. So this ensures that all the power from the transceiver will be reaching the antenna booster and will be transmitted into space. And for more complex scenarios, as I said before, in this case, what we illustrate is an automatic process to design from single band to multi-band matching networks. So in here we illustrate an antenna booster. Here will be the layout to allocate the matching network. So 1, 3, 5, 6 represents a series component. 2 and 4 represent a shunt component, and port 7 represents the feeding, the transceiver. So by simulating the S parameter of this structure, we can use this in kind of genetic algorithm software like OptanyLab or Cadence Microwave Office and say, hey, what I need is to have in here, I need to have my RF source to transmit power and reach the antenna booster. So choose me to select which component has to be in every port. So do I need a series inductor or do I need a series capacitor? And beside that, which value do I need? So this can be done in automatic fashion. We don't need to use complex formulas. We don't need to fine tune or trial and error process. This is totally automatic. So let's see now some examples now that we understand the physical behind and the architecture. Let's see how this technology helps to design from single band to multi-band antenna system. In this case, we have a PCB with an antenna booster. It's lambda over 30. And in this particular case, with a very simple matching network, only 2 inductors, we can have a LoRa. LoRa is a long-range protocol able to connect devices for the IoT space. As you can see, this is measured SWR. And the most important, the efficiency, it's about 90% across the frequency bands of 900. Now imagine that we have the same device, but we have another application that needs multi-band operation. In this case, you can see this is the same device, but now we want a multi-band operation, and the only thing we need to change is not the antenna booster, but it's the design of the matching network. In this case, we have 5 components, capacitors and inductors, that with this automatic process, we can achieve a multi-band behavior in a first region around 900 and in a second region about 2 giga. This can be an example for narrowband IoT or LTE-M. And even more challenge. Imagine that we need to expand the frequency range up to 2.7 giga with the same platform because we have a new application. Everything is the same, and the only thing that changes is the matching network. In this case, we have 7 components, 1, 2, 3, 4, 5, 6, 7 components between inductors and capacitors. And again, the topology and the values that fits in is selected by this kind of artificial intelligence method that picks up the topology and the commercial values to maximize the efficiency we need to obtain in the frequency bands of operation. And this is a real device from the company NovaThings for a smart agriculture. This is for achieving operation at several bands in around 900 as well as around 2 giga. You have one frequency region and also another frequency region with this antenna booster that is not only multi-band, but it's also multi-radio. It means that the antenna booster can have one port for narrowband IoT and another port for GPS. So this is an important message because this technology, besides being small and multi-band, it's also multi-radio. You don't need to have 2 antennas, one for narrowband IoT and another for GPS. With the same antenna booster, you can have both radio protocol operation. Also for MIMO, for those interested in researching in this domain, there is a lot of research to do. This is only an example of what we can get with antenna boosters. In this case, we have 4 antenna boosters at the corner of the ground plane because it's usually the best position. And with a proper design of a multi-band matching network, we can get operation across these 2 frequency regions. You can see here the S11 response for every single antenna booster. Okay, now that we saw that matching network play a very important role, the question is, okay, but what if my matching network cannot get enough bandwidth for my application? At the end, you cannot get infinite bandwidth. I mean, you can put 10 components, you can increase the bandwidth, but there is a limit. So the question is, what can I do in those applications where I need more bandwidth and my passive matching network cannot give me that bandwidth. For those cases, what we can use is tunability, so reconfigurable matching networks. And we are going to illustrate two examples. A first example is with digitally tunable capacitors, and the second example is with RF switches. A digitally tunable capacitor is a capacitor that can change its value from one minimum value, say 0.5 pico, up to another maximum value, depending on some signaling that drives this capacitor to a particular state. And RF switch, in this case, what we have is a component that, depending on some signal control, you can change the state and the input can go to another output. In this case, we have one input that can reach one output, another output, and so on. So let's see how we can combine these tunable components with antenna boosters. Here we have a ground plane with an antenna booster. And in this case, we have a passive matching network. These components that you can see here, this is a 50 ohm transmission line just for testing purposes. In real life, you will have here the transceiver. Okay, but for testing purposes, we need to attach this transmission line. So in here, this matching network, you can see with inductor and capacitor, it has an extra component, this component here, which is this black dot here. This is a digital tunable capacitor that it can change the capacitor depending on some signaling that we can control. So as you can see that as a result, we can tune, and depending on the state, we can get a better efficiency if we change the state of the capacitor. In this case, the passive matching network was not enough to provide operation in the low frequencies around 700. But with this tunability, we can create an state with a good matching as a result, a good and acceptable efficiency to have operation along this frequency region. And let's have a look at the second approach. The second approach uses RF switches. And this technology, this architecture, is an example that we have implemented for this device from Nordic Semiconductor. Is the Thingy 91. It's an IoT sensor. It's only 50 by 50 millimeter. It's very small, and it has to operate across these narrowband IoT LTE bands, 700, 960, plus 1710 up to 2200 megas. So with a passive matching network, was very difficult to achieve an acceptable performance. So what we did is, okay, let's split the problem into small problems. So we have the transceiver, we have the antenna booster, and what we did is we designed a simple matching network to achieve a narrow band behavior, as you can see here, but with several matching networks, we can cover the whole frequency region. So this is how it works. If we need to operate in this frequency range, the transceiver has the intelligence enough to send some control data to put this RF switch and this RF switch in this state. So the signal travels from here to here. We have a good matching network, so we don't have any reflection. The signal goes through this matching network, reaches the antenna booster, and goes into space. The same happens if we now need to operate in this frequency region. The transceiver changes the state of this RF switch and this RF switch, and so on, and so on, and so on. So you can see that we can cover the whole frequency range by splitting the problem into a small matching, narrow band matching network. And in this case, this is also useful for GPS. Imagine that we receive the GPS from the satellite. This is a matching network for GPS. Then there is no reflection, so all signal goes through the matching network. This is amplified by a low noise amplifier and enter the transceiver in the GPS. So you can see that we don't need a GPS antenna. With the same antenna booster, we can have a multi-band operation for LTE plus GPS in the same antenna booster. So let's illustrate how it works with this video. You can see, depending on the state, we have a good matching network. In blue, we have a good matching network in the low frequency region. Then in pink, a little bit beyond. In the brown, in the higher frequency. You can see that with very simple matching networks, we can cover the most challenged frequency region, which is the low frequency region. So to sum up, the tunable solutions are very convenient where a passive matching network cannot provide enough bandwidth. So let's talk a little bit about this matching network synthesis. So we saw before that designing this matching network, it's very simple. And in fact, it is, and it can be very automatic. So the problem is very simple. We start by selecting our device, our PCB size. We select our antenna booster and the position. Usually we place at the corner of the ground plane to have the best bandwidth and efficiency. Then we define the frequency bands of operation, and we specify the efficiency we can get or the S11. And with this input data, we use any kind of microwave circuit simulator, such as Opteni Lab from Opteni, Microwave Office from Cadence, or ADS from Keysight, or perhaps you can do your own stuff. And with this input data, we tell this matching network synthesis tool, which is mainly based with advanced genetic algorithms tools, to synthesize the matching network if it needs 4 components, 5, 6, 7, the topology, as well as the values that we need to achieve the frequency response. So let's have an example. On the left, we have the simulated PCB with the antenna booster. We run the simulation. We need to have operation across this multi-region, these multi-band frequency bands. And the simulator told us that we need this topology with 7 components and with these values, even commercial values. This is very powerful because these are commercial values that then you can build in your prototype. So we took the very same components that the simulator told us. We implemented the same PCB, the same components. Here you can see these blue components are the inductors, and the gray components and the capacitor. And these are SMD components. And this is what happens once we implement into a real PCB. This is the total efficiency. And in green, what we have is the simulated data. And in red is the measured data. This is a very good agreement without any tuning. So the very same components of the matching network, they were implemented in an automatic fashion. So this means that to design multi-band antennas or multi-band antenna systems for wireless devices, it's very simple because we don't need to have any human intervention if we do with antenna boosters. Let's have another example. In this case, we took different PCB sizes for a smart meter, a smart tracker, a sensor, from a big one to a small one. And what we did is, okay, we need to operate across low frequency region and high frequency region, typically from narrowband IoT. And we designed the matching network using an antenna expert, and we designed it through this automatic process. And we compared the results in terms of total efficiency. And the conclusion is that results are pretty much the same. And the advantage is that for the human-based method, it took days, to find the best matching network, because the human needs to rely on testing several matching networks to find which is the best one to achieve the bandwidth. And this means trial and error, building prototypes, and it's quite an iterative process that can take days. However, with this computer-based method, based on antenna booster and this automatic process, it takes less than 1 hour to simulate and to obtain the matching network and to implement into a real device. So this is a very simple and fast to design multi-band antenna systems. Okay, let me show another example. This is for a smart tracking platform, and we need to operate across many frequency bands. The simulator told us that we need this matching network with 6 components, and we implemented into a real PCB. You can see here a detail. This is a shunt component, which will be this component. It's an inductor. Then we have a capacitor, which is here, and so on. So once we implemented, and when we compare with a matching network that has been designed by a human expert, the human expert took almost 1.5 weeks to reach the suitable topology and values of the matching network, whereas only took less than 1 hour to obtain the matching network and to implement into a real device, and with only 6 components. And not only that, not only it was faster, but also in terms of efficiency, it was better. You can see in pink color, this is frequency, and this is total efficiency. In pink, we have the total efficiency obtained by the human-based method. As you can see, the blue line in here it's better, and in this case, it's always better across the whole frequency region. So this opens the window.
Dr. Jam,
Yeah?
sorry to interrupt you. You are muted. Can you please unmute?
I'm muted?
You are muted, sir. Can you please unmute?
Okay. Wait. No, I'm not muted.
Yeah, fine, sir. Fine. Now fine, sir.
Okay, can you hear me? Hello? Can you hear me? Hello? Hello, Samir? Can you hear me? Okay. Can you see my screen? Okay, so so this automatic process opens the window that in the future, in the near future, robots will make the antenna designs, because as you saw, all this process, it's very automatic. The simulation can be done with software. The selection of the matching network can be done by software. The selection of the antenna booster and those of the shelf SMD components can be done by a robot and installed into a real PCB. And then the question is, okay, then what we are going to do? Then, well, we will do other smart things in the antenna space. And to conclude the presentation, just 1 minute more. And in this slide, I would like to compare antenna booster with self-resonant antennas based on more complex geometry, based on my own experience when I was working in South Korea for 3 years for the main players in the mobile space. In here, we compare both antenna technologies, where you can see that if we need to operate in this frequency region, the typical volume for these self-resonant antennas, it's about 1,000 millimeter cube. It's only less than 100 millimeter cube. It's 10 times smaller. This is a good number to remind. 10 times smaller compared to other technology. In terms of designing, either in the simulation or in the lab, it takes days to reach the final geometry, whereas in antenna booster, the antenna booster is done, and the only thing we need to design is the matching network, which is very fast. To design self-resonant antennas, you have to be an expert in the antenna field. To design multiple antenna systems with antenna booster, you need to be an RF expert, but not an antenna expert. So this is more open technology to be used by a whole spectrum of experts in the RF space, microwave engineers, and so on. Can be self-resonant antennas used for other frequencies? No, because once the antenna is used or resonating on some particular frequencies, you cannot reuse at other frequencies. You need to design a new antenna from scratch. With antenna booster, the only thing you need to do is to change the matching network. And easy to integrate? Well, it depends. If you have a very narrow IoT device, this kind of self-resonant antennas may be difficult because they are small, but not small enough. In this case, we can have a very narrow device that even though the antenna booster can fit in that device. And for MIMO, as you saw, in this case, if we need to have MIMO 4x4, it's going to be difficult because the antenna is big enough and only you can put two antennas in one corner and in the other corner. But with antenna boosters, we can put one antenna at each corner of the PCB. And just I'm running out of time, so let me conclude. As you saw with this antenna booster technology, this is small, there is a multi-band, they are off the shelf and also pick and place, easy to install in a PCB. And designing antenna device, wireless devices with this technology can be addressed by a totally automatic process, which is much easier and faster than using the technology based on antenna geometry. And this is a proven technology that it's commercially in many products in the IoT space for trackers, smart meters, and so on. There is much things to do in this space, so I encourage you to research on this topic. I would like to say thank you to the European Commission and Spanish Ministry for funding this research. Also, Professor Shatis and Professor Samir, my friends, for organizing the event and inviting me. Also, the IEEE BISAC Day chapter for supporting this event. And of course, all attendants following from home or from the university. Thank you for watching. I hope this presentation was useful. And at the end, I have all this further material in case you want to research and do your own stuff. Please have a look at these webinars. And also we have many materials that you can use. You can use these antenna boosters with CST. They are available in our web page. And also plenty of reference that you can use for doing your research in master level or PhD, that I hope these materials can be helpful to continue research. And if you belong to another chapter, I am IEEE Antennas and Propagation Distinguished Lecturer, so don't hesitate to contact me at jaume.anguera@ignion.io. I will be glad to have a lecture in your IEEE chapter. So thank you, and I hope the presentation was practical and interesting and useful for you. Thank you very much.
Yeah, thank you very much, Dr. Jam. It was really exciting to listen to you once again on the on your most favorite topic, that is virtual antenna and antenna boosters. Really, every time I see that there is something new in your presentation. Even tomorrow also, if I attend, I find something new. I don't know how you people are managing it, but always there is something new finding that you are including in your presentation, and that makes us delighted and excited also. And this time I see a lot many things which include that the new name coined to your company, that is Ignion.
Yeah.
Yeah. Yeah, that was really first thing. What exactly do you mean by Ignion? So is there any
Okay,
specific?
that's a good question. We changed the name Fractus Antennas because it was very close to our parent company, it's Fractus. So we call Ignion because Ignion comes from the word ignite, which means boost, expand. So since our technology is called antenna booster, we call ignite. So ignite, ion, it's a particle. So well, ignion, it reflects boosting power. So these are the name of the company that it reflects empowering the IoT space with antenna technology.
That's excellent. Yeah. So you have done a lot of research even in coining your name. That's great.
Yeah.
Yeah. So always I feel like this is a miracle. In fact, this virtual antenna, the concept itself seems to be, not convincing at the initial stage because an antenna is suitable for all applications in a particular spectrum, covering a large, covering a large spectrum is not a simple task, but you have really realized when I first heard about this and got into the details of it, and when you explained it, if you remember 2 years ago you have been delivering a lecture to the IEEE Vizag based subsection, and that's the first time we got a clear idea and the picture on how you have really realized the concept of antenna booster and the virtual antenna, or the concept of antenna-less devices. So this is a very kind of not just a simple technical lecture, but it is like a demonstration. I could see that antenna that you have shown practically in your between holding it between your two fingers, right? That was really exciting to see, and. Yeah, we have been actually getting some emails from your company, but how do we approach you to extend the research in it? We have been actually trying for that, me and Dr. Satish. We wish to do that, some extension to that work, antenna boosters, in this particular laboratory where we are, and we have given you all the specifications. So we are really excited. We have a team which can actually work on it. We have been associated with several other activities with you, which includes antenna array and evolutionary computing tools and that fractal antenna, the age-old, which we have published nearly 3 papers. But we need your support so that we can continue the research on antenna boosters in this laboratory. That's what the word from our chairman, from the management of Raghu Institute of Technology, as well as my HOD and your friend Dr. Satish too.
Okay, so I'm glad. Yeah, I think that's one of the approaches. I mean, we can discuss offline always, but we can engage your research team. You have master students or even PhD students, and we can think on new research line where we can shine as having new results, for having publications and get fundings in the government. So yeah, you can count on me on helping to drive in which direction we can work, and you can count on me on providing the support. So let's do one thing. Let's chat with email this day, and let's discuss how we can bring this into a real thing. It would be nice that we can engage people to research in this domain.
Yeah, definitely this is a message to all the participants, because I see participants are even from NITs and IITs, and many participants are also from several universities who have joined with us today. So this is like a message to them. In fact, they can also utilize this opportunity, and we can all collaborate and start some work. That's a really great opportunity that you are giving to us on this platform. So
contact me for those from other universities. Please send me an email, and let's figure out how we can expand collaboration. Yeah.
Yeah, thank you. That's a great opportunity, really. So I request Mr. Akash to propose the vote of thanks so that we can close the session. and start over with the other sessions. And really, once again, thank you, sir. So I over to Akash.
Yes, sir. Am I audible, sir?
Yeah, you are perfect.
So I'm honorable to respect our great thanks and extend our support and a clear message from the participant. All are enjoyed your session, sir. And mostly you have touched the latest topic on a virtual antenna and reconfigurable of the virtual antennas with the MEMS. And you have also enlightened the deep topics like impedance matching networks with the thing and various sensors and the usability of the GSM and applications with the antennas. And you also compared your virtual antenna with conventional customizable antennas. So you given a complete technology of the virtual antennas, which are easily fabricatable and easy of the integration. So all these topics will help a lot in this section, sir. So with these things, we are very much helpful for your great lecture on this side. Another great day. Having a nice day, sir. Thank you, sir.
Yeah, thanks. On behalf of the management of Raghu Institute of Technology and Raghu Engineering College, a special note from Chairman, a big thanks to you for contributing to our international conference on computing, communication and power technology IC3P 2022, as well as there is even a message from both the principals, because here in the campus we have two engineering colleges. A clear message from both the principals. A big thanks to you once again, and you have been always a big support to us. And this Akash is the person who is working on HIS. He is still carrying out the work through the note that you have provided to us. In this way, you have contributed or helped or supported us in many ways, sir. So a big thanks to you on behalf of the organizing committee, on behalf of the IEEE Vizag based section and IEEE student branch of Raghu Institute of Technology and Raghu Engineering College. Yeah,
Thank you. It's a big pleasure always to be here anytime. Once again, thank you to the IEEE VSAC. Thank you to all organizers. Thank you to all academic professors, to all students, and in particular, thank you to my friends, Professor Satish and Professor Samir. Always, anytime. I wish you all a happy new year. Stay safe and stay well, and keep in touch.
Namaste. Yeah, thank you.
Namaste. Dhanyavad. Dhanyavad.
Dhanyavad.
Thank you.
Thank you, sir. Thank you.
Thank you.
Yeah.
Thank you all.
Yeah. So thanks all the participants. You please join for the next session, your sessions. And that's it. So I'll be ending the session with the permission from Jam, Dr. Jam. Yeah. So thank you, sir. Thank you. Yeah. All the participants, please note, you can leave the session and you can join your presentation session, session number 3 and session number 2. Two offline sessions are going on. You can directly physically present in my department of ECE Raghu Institute of Technology and go to your respective rooms and start your presentations. Once again, thank you very much, Dr. Jam, for joining with us once again. Really, you have been an excellent support. And I also once again thank the principals of Raghu Institute of Technology and Raghu Engineering College and the chair of IEEE Vizag Bay section and the chair of ComSoc SPS joint chapters, Professor Dr. T.S.N. Murthy Garu. And I also thank Sriram Garu for being with us through the session. Thank you very much, sir. So with the permission, I'll be ending the meeting. Thank you.
Thank you. Bye-bye.
Thank you.